Hi students, Mrs. Sims here. For our second video lesson, we are going to talk about solving equations with variables on both sides. You do have this paper in your note packet, so if you want to find this page that says solving equations with variables on both sides and follow along, feel free to pause the video as needed to do the work and take a second to think through it. So if you notice just by looking at these equations, they are a little bit different than the one-step, two-step, and multi-step that we've been doing because there are variables. There's an x on this side and there's an x on this side. We know that when you're solving equations, you want x on one side and numbers on the other side so that you get a solution, x equals 5 or whatever. So we haven't had anywhere it has variables on both sides. So let's go through the steps and then we'll do examples that'll make more sense. So to solve equations with variables on both sides, you move the coefficient terms, that's like the variables basically, to one side of the equation. Coefficient terms to one side of the equation. That's basically just the variables. You move all the x's to one side. Then you move the constants. Remember, constants are just numbers by themselves. So you just move the numbers to the other side. That's what we want. We want x's on one side, number on another. Remember that like terms have the same variable raised to the same power. So we know when you're combining 5x and 3x, those can be combined, but 5x and 3x squared cannot be combined because they have a different power. So you would combine like terms and then use properties of equality to solve the equation. That's the addition property, subtraction property, multiplication or division property of equality, which basically is just whatever you do to one side, you have to do to the other to keep it equal, to keep it balanced. And then you solve each equation. So let's look at what that actually means when you're solving. So we still draw a line down the equal sign, but we have x's on this side and we have x's on this side. I need to get rid of one of the x's from one of the sides. Now, if I decide to get rid of 8x, then there's nothing left on this side of the equation. So that wouldn't really make sense. So I want to get rid of 4x. Now, usually I'm just trying to get rid of 4, but I'm trying to leave x, so I divide by 4. But this, I'm trying to get rid of the entire 4x. So to get rid of the whole 4x, I'm going to subtract out 4x from both sides. So you're asking yourself, which side can I completely get rid of an x? This one makes the most sense because then there'd be x's over here and numbers over here, which is always our goal. So we are going to subtract out the entire 4x. So 4x minus 4x is 0. So all we're left with here is negative 2. On this side, 8x minus 4x is just 4x. Now at this point, you just have a one-step equation. You've just got to get x by itself. X is being multiplied by 4. So the inverse of that is to divide by 4. So we're left with x equals negative 2/4 or just negative 1/2. If you want to simplify that fraction, that would work as well. So the idea again is to get rid of x's from one side. It makes sense to get rid of usually the lower one. And I'll show you why on this example. So on this next example, 7x plus 5 equals 8x minus 4. So we have numbers and variables on both sides. We want numbers on one side, variables on the other side. So I need to either get rid of 7x or get rid of 8x completely. It does not matter which one you do. You can get the right answer doing either of them, but it makes more sense to me if I'm going to be subtracting either 7x or 8x, it makes more sense to subtract the lower one. Otherwise, I'm dealing with negatives. If I do minus 8x, then I've got a negative x over here, and that's going to add a step. So it makes more sense to get rid of the lower coefficient. So 7x, to get rid of 7x, remember I want it completely gone. I don't just want to solve x, I want the whole thing gone. So I'm going to subtract out 7x from both sides. So those 7x's go away, which is why I did it. All I'm left with is 5 over here. Over here, I have 8x minus 7x, which is just 1x or just x, and then I still have the minus 4. Now, again, I'm at a one-step equation. I've got x already by itself. I just need to get rid of the minus 4. The inverse operation of subtracting 4 is to add 4. So then I'm left with 9 equals 1x, or just 9 equals x. You know, you can always check this. So if I put 9 in for here, for x, I can double check that I am correct. So if I solved that out, 7 times 9 is 63. 63 plus 5 is 68. 8 times 9 is 72. 72 minus 4 is also 68. So if 68 equals 68, I checked and it is correct. Okay, I'd like you to try the 5x plus 11 equals 3x plus 7. Go ahead and pause the video and see if you can solve that one on your own. Okay, for this one, I need to get rid of one of the x's first, either 5x or 3x. I'm going to choose 3x just because it's smaller and it won't make me have to deal with negatives. So if I subtract 3x from both sides, 5x minus 3x is 2x plus 11 equals, this one went away, that's why we did that, equals 7. Now I have a two-step equation to solve. I've got x is my variable that I'm trying to isolate. They are adding 11 and multiplying by 2. Remember, we always do PEMDAS backwards from this point, so I want to get rid of the plus 11 by subtracting 11 from both sides. So I'm left with 2x equals negative 4. To get x by itself, we're going to divide by 2. So x equals negative 2. Okay, on this fourth one, notice you have parentheses, number on the outside. So hopefully you're thinking, oh, I need to use the distributive property first. So we would first distribute the 7, and then we've got x's on both sides. Then you have to decide how many x's you're going to get rid of completely, and then solve like normal. So pause the video for a second and solve that one. Okay, for this one, 7 gets multiplied by everything inside the parentheses. So 7 times 4x is 28x, plus 7 times 2 is 14, equals the 20x minus 50. Okay, now I can actually start to solve. I've got 28x on this side and 20x on this side. I'm going to subtract 20x from both sides so that this side will get rid of all its x's. So 28x minus 20x is 8x plus 14 equals, and then we're still left with a negative 50 over here. So then I want to get x by itself. I'm going to get rid of the 14 by subtracting 14 from both sides. So I'm left with 8x equals 64, which is a negative 64. And then to get x by itself, divide by 8, divide by 8. So x equals negative 8 is what you should have gotten on that one. Okay, let's look at the back. There are 6 problems for you to solve. That one's got fractions. What I want you to do is go through and solve those. Pause the video, and it may take a while to solve those 6, but then come back and I'll have the answers for you so you can at least check your answers. Okay, feel free to pause the video wherever to look at these solutions, but I'm just going to give you the answers so you can check. Number 1, I got x equals negative 3. Number 2, I got x equals negative 1/5. You may also have gotten negative 0.2. That is the same. Number 3, I got x equals negative 6. Number 4, I got x equals negative 11. Number 5, I do want to point this one out on number 5 on the process. Looking at the very first step when I had negative 3x and 7x, I decided to get rid of the negative 3x. Now the inverse of that, the opposite of that, in order to get rid of that, I had to add 3x to both sides. So that one was a little different because we had a negative x. So I counteracted that by adding 3x to both sides. And then my final solution was x equals negative 1/10 or negative 0.1 if you left it as a decimal. Then number 6, I got x equals 3.25 or 3 1/4 if you left it as a fraction. For today, you will have practice on solving with variables on both sides. You've got a practice worksheet to complete for that. If you finish that, then you can also be working on big ideas online. Have a wonderful day.